Hello viewers, welcome to this video lecture series on computer networks theory course. So this session I shall continue with the previous session. Previous session I started with OSPF, Open Shortest Path First Routing Protocol, and in that protocol I have explained the working of protocol as well how the forwarding tables get constructed. Now in this session I shall explain you the different types of link state advertisements that happen in OSPF, the header format and the OSPF messages. OSPF is based on link state routing, and that requires the router to advertise always the state of each link to all the neighbors for the formation of LSTB. So every router is going to construct what? Link state database. How it is going to construct the link state database? Based on the LSPs information received from the neighbors. So suppose if you have here the router R2 and it is connected to the router R1 this side, and this side is your R3, then R2 will be receiving from R3 its LSP and R1 will be sending its LSP to R2. So R2, when it collects the LSPs from both this R1 and R3, it is going to construct what? It is going to form the link state database. Other routers which are connected to R1, they would have forwarded their link state information, which in turn R1 will send to R2. Similarly, the other routers which are connected to R3, they would have sent their link state information to R3, which in turn R3 would have forwarded to R2. So finally R2 is having what? The link state information about all the other routers in the network. So with this link state advertisements only, each router is maintaining the link state database. So there are 5 types of link state advertisements in OSPF: the router link, network link, summary link to network, summary link to AS border and external link. So these 5 different LSPs are shown here in this diagrams, diagram A, B, C, D and E. So basically the link state packet, okay, this information is flooded in the network by the router. Now every router, when it is trying to send the link state information or receive the link state information, so those link state information, whatever we say link state packets, are having these 5 different types of advertisement mechanisms. In the router link mechanism, you can check here, it can be what? Via the transient link or the point-to-point link and the stub link. That means the router information can get update directly from the router itself. There is no network in between. We call it as point-to-point link. Whereas in the transient link, you can check there are 2 possibilities here. Each router is connected to every other router in the network, or there is one designated router to which all other routers are connected. The stub link, it is a network that is connected to the single router. Data enters to the network through the single router and leaves the network through the same router. We have the second type of link state packet advertisement, the network link. So in the network link, you can check here, the network information is advertised by a designated router only. This router is the one, okay, the designated router which is going to take the information from the complete network and it is going to advertise it. We have the summary link to network, summary of the routing information from area 1, you can check here, it is sent to the area 0, that is the backbone area via the area border router. So that is called as the summary link. Also we have from area 0, that is the backbone area, okay, the link state advertisement packets reaching to the AS router. AS router is the border area router for other autonomous systems. So that particular AS router you can see here in this previous diagram also. Check here, this is your from area 0, this is the AS boundary router. This is connected to other autonomous systems. So this link, okay, this link is what? Is one of the type of the link state advertisement, and it is called as the summary link to autonomous system. Then from this autonomous system router, it is sent to the other networks. So that becomes, that link is called as the external link. So these are the 5 types of link state advertisements. So now let us see the OSPF messages. It has got 5 different types of messages. The first one is the type 1, which is called as the hello message. The type 2 is the database description message, and type 3 is the link state request message. Type 4 is link state update message, and type 5 is link state acknowledgement message. So these are the 5 different types of messages that are used by the routers. Now if you look into the first one, the type 1 message, it is used by a router to introduce itself to the neighbors. Definitely, a router, when it is included in the network, it has to introduce itself to other routers in the network. So for that purpose, it uses what? It uses the hello message. The data description, the second one, the data description message is normally sent in response to the hello message to allow a newly joined router to acquire the full LSTB. So whenever router R1, which is the newly joined, when it sends the hello message, and in response to the hello message, it receives what? The database description message. And in this message, which it receives from its neighbor, it will get to know the network information from its neighboring router, so that it will acquire the full link state database information. The third type of message is the link state request message. If a router R1 wants to know the link state information, that is a specific link state information, then it has to make use of the link state request message. Fourth type of message is the link state update message, and this is the update message, and this is the main OSPF message. Every router in the network has to send its link state information to its neighboring routers. So it can make use of the link state update message to send its link state information. So this link state update message itself in turn is having what? 5 different types of links, and this is what I had just explained. One is the router link, network link, summary link to network, summary link to autonomous border router, and external link. And the last type of message, the fifth one, is called as the link state acknowledgement message. And whenever a router receives a link state update message, it has to acknowledge it. Suppose now let us take there is one router R1 and it is sending what? Its link state information to R2. Then R2 has to respond to that with a link state acknowledgement message. So that is what is needed also in networking. To create reliability in OSPF, this link state acknowledgement message is used. So these are the 5 different types of messages. Next topic is the OSPF header. Let us see the header format for OSPF. So this is the diagram. The same diagram I have drawn it here also, because in some textbooks it is given as packet length, in some textbooks it is given as message. Both means the same, but let us see here the different fields. The first field is the version field, the version of the OSPF. There are 2 versions, version 1 and version 2. And the next one is the type here. So as we have seen, there are 5 different types of messages, type 1 to type 5. So which type of message is there in the header, that information gets included in this field. Then we have the message. This is the actual message here, okay. 16 bits are used. Then we have the source IP address. Now what is this source IP address? The router which is that means the sending router, the router that is sending the message, okay, that's router's ID or router's IP address becomes the source IP address here. Then we have the area identification, because OSPF what it functions by dividing the autonomous system into different areas. So is it area 0, area 1, area 2, that area ID information will be included in this field. And here we have next the checksum field. 16 bits are meant for the checksum, because to detect errors checksum field is very much required. Then we have authentication type here. Authentication type will have only 2 values, either 0 or 1. 0 is no password required, whereas if the value of the field is 1, that means a password is needed. Authentication is the 32-bit field that contains the actual value of the authentication data. Let us see a few points about the OSPF implementation. It is implemented as a program in the network layer using the services of the IP for propagation. The IP datagram that carries the message from OSPF sets the value of the protocol field to 89. So you might have seen the IP header, okay. In the IP header there is one field, okay, which is called as the protocol field. This protocol field will always have a value, and that value indicates which protocol message this particular IP datagram is carrying. So here if the value of the protocol field is 89, that means what? It is carrying the message from the OSPF protocol. So this OSPF protocol, although it is a routing protocol to help the IP to route its datagram inside an autonomous system, the OSPF messages are encapsulated inside the datagrams. OSPF has 2 versions, version 1 and version 2. Most of the implementations uses version 2. So this version field is also included. I have shown here in the header format. The first 8 bits are used to denote the version field. So this is all about the different types of LSPs, different types of messages, and the header format of OSPF. Hope you find this information useful. Please like, share and subscribe to my channel. Thank you. Bye bye and take care.